Hello and welcome to our webinar on circular economy in the solar PV industry. My name is Munib Amin. I am one of the managing directors of E.ON Group Innovation, where I'm responsible for academic collaboration. At E.ON Group Innovation, we work with top scientific institutions to solve the most pressing challenges of the energy transition. And that is why I'm happy to say that we teamed up with Cambridge University to investigate the topic of circular economy. Now, why is circular economy so important for the energy industry? The massive expansion of renewable energy sources has caused basically a shift from the industry's hunger for fuel to other resources like materials and land. And I'm frequently asked, for example, how long is copper going to last? How long can we still buy components for our grids that are made out of these materials? And I believe that this is the wrong question. The right question to ask would be, how can we make the best use of the materials that are available and the resources that we can use? And I'm very convinced that circular economy will be an important building block here. Now, if you could go to the next slide. In today's webinar, we would like to give you an overview of the research that we did with Cambridge University on circular economy in the PV industry. And we have a tight agenda. So first of all, my colleague Nadine from Central Sustainability at E.ON will give you some context, and then you will have a presentation about the key findings of the report. And then I'm very happy to say that we have a small panel with experts from the industry and policy and the academic environment. And yeah, last but not least, you will have the opportunity to ask questions. Now, you can post your questions in the chat, and please be a bit patient until the end of the webinar. Then we will collect your questions and distribute them to the speakers. You can already download our report if you follow the link on the QR code that you can see on this slide. But please don't start reading now. We are now very anxious to see the speakers of this webinar. And with that, I hand over to Nadine.
Yes, hello also from my side. I'm now working for a couple of years in the field of circular economy, and it was great to see how the subject has been evolving from a niche to, I would say, almost mainstream subject. So really a lot of companies are now start talking about the subject. And in parallel, we have seen that there are a lot of geopolitical challenges ahead. So there was also the question now for E.ON Group, how we should react to these two trends. How should we incorporate circular economy measures into the energy sector on our company? And that was also exactly our starting point for our circular economy strategy. We set up a story that was easy to understand, define a bunch of no-regret measures to showcase that there's a lot to gain, as we will see today, hopefully, and prioritize in the most pragmatic way components that are vulnerable to external impacts, such as supply chain outside EPU, as we see for the solar PV panel industry, but also components and assets where we expect a major waste streams to come up in the next couple of years. Furthermore, we understood that circular economy does not stand for itself. It requires a holistic approach to measure impact. Resource usage is an important topic in a world that is heading into material scarcities, but also in terms of environmental and social aspects, especially if you look at mining and production sites for raw materials. Altogether, this led us to set up a so-called nature strategy that will create our guiding framework in order to become a more circular company, taking into account all our strategies. Recycling, refurbishment, and reusing are more in focus on this. To become more active, we also understood that we have to go more into the value chains and understand where our levers as a most a company that is not a manufacturer, and deep dive there in our opportunities to collaborate with suppliers and startups. And therefore, I'm really happy about the study because I think it provides a good basis to draw out our strategy angles, but also it's nice that we have a research piece of work that is open for everyone. And it's really helpful also for startups or other companies. And I'm also really looking forward to the input from Ascent, because I think this is also a good example how a study like this can be implemented really in a short term. So thanks again for everyone who was providing input into the report, and I'm very much looking forward to the next half an hour and all the discussions. Munib.
Thank you very much, Nadine. And now, without further ado, I would hand over to the research team. First of all, Diana Kripko, who worked as a researcher on that study and is part of the Institute for Manufacturing at Cambridge.
Thank you, Munib. And I will start with giving you a brief overview of our project, of the objectives and our approach. So our main objective was to understand to what extent can we use circular principles and circular economy approach to create more of positive social, environmental, and business or economic impact within the PV industry and outside of it. So how can we leverage circularity in order to generate greater impact? Our approach consisted of different methods. We conducted a very in-depth technology assessment using innovation velocity tool developed here in Cambridge to understand the technology implications towards circularity. We conducted an in-depth literature review and used a framework, another analytical framework, to understand what are the different drivers and barriers to circularity, and what is in general the market perspective and any other key contextual conditions which need to be considered when we look on how can we change this industry to become more circular. We have mapped the value chain and the different stakeholders in this ecosystem in order to understand how it looks right now, and also, of course, to think about how it may look like in a circular economy world. And finally, we conducted an in-depth interviews to validate the findings and basically to derive the recommendations on what are the implications and considerations for industry, for policymakers, and the broader society. So in terms of our approach, we had also very extensive engagements with different experts and stakeholders across industry, policy, and research. Next slide, please. Thank you. So now just a very short summary from where we started the journey from the technology perspective. When we started here, we obviously identified that there are actually many different solar cell technologies. There are some technologies like crystalline silicon and cadmium telluride, which are already in a broad application in this industry, but there are also many different other emerging technologies. So here we wanted to understand how these technologies perform in comparison to currently prevalent technology, which is crystalline silicon. And what you can see on this map on the right-hand side of the slide are the different perspectives which we looked at, so efficiency, durability, and lifespan, availability and affordability of resources, toxicity of raw materials used in the solar cell technologies, but also to manufacture them, implications in terms of resource intensity of manufacturing, and also aspects related to the recyclability of those technologies. And what we have identified that in comparison to crystalline silicon, and you can see its performance shown in gray, other technologies currently are mostly performing less good, except of one area, and this is where we talk about resource intensity of manufacturing. So this gave us the understanding of that the remaining parts of the study, we will focus on silicon-based PV, because other technologies are on horizon, but the issues which we are facing right now towards the end of life of photovoltaics are mostly related to this particular technology. Next slide. So, of course, solar PV is one of the key technologies in energy transition, and we see a rapid growth of this technology driven by falling costs, improved efficiencies, and also, of course, by the global and national net zero targets and ambitions. But with this growth, as the status quo is, at the moment, when at the end of their lifespan, photovoltaic panels usually end up, or mostly, like in terms of their mass, end up in the landfill. So if we continue business as usual, it will mean with a growing amount of installed capacity, we will also see a massive increase in the waste. And we talk about electronic waste here. And of course, this has plenty of environmental and societal challenges and issues and actually damage associated with it. So now I would like to hand over to Sana, who will talk about the next stage in our journey.
Thanks, Diana. So basically, where we started this project from was to look at what or how the value chain for solar PVs currently looks like. And this is, in a way, a very simplified stakeholder mapping exercise where we looked at which stakeholders are most involved and therefore when we start thinking about circular economy solutions, which stakeholders we need to involve in those conversations and which stakeholders need to change their operations. So here, this is a linear value chain. So this is the predominant way in which solar PVs go through life at the moment. Obviously, in the EU, we have regulations such as requirement to recycle 80% of the weight of the solar PV. But in this report, we looked at what would be better options in terms of circular economy and what circular economy solutions or strategies could potentially offer more valuable outcomes. So we took this as a starting point. We looked at what needs to change, what new stakeholders need to emerge for us to move to a more truly circular and sustainable solar PV value chain. So if we go on to the next slide, this is basically the way that we identified circularity and the circularity imperative. We use the EU Commission's 4Rs approach, which includes reuse, repair, remanufacture, and recycling. And the approach effectively focuses on keeping materials, products, and resources in use as long as possible, reducing waste, whilst also retaining the value of these materials for as long as possible. And because of this approach of retaining the value of the materials for as long as possible, some of the second life strategies, such as reuse, repair, and remanufacture, are actually preferable to recycling. So if we move on to the next slide, this is the circular value chain, and this is very much an ideal circular and sustainable value chain which we created that could emerge for solar PVs. And as you can see, this is way more complicated than the linear value chain. Some of the operations here on the right are now beginning to emerge, such as repair services, disassembly services, decontamination services, and so on. So we have these services emerging, but they're not yet major stakeholders. They're often not financially viable, and they kind of exist in the margins of the solar PV system. So on the left here, we identified a number of exogenous stakeholders. So these are stakeholders who influence the ability of the stakeholders in the solar value chain to make the changes that are needed to become more circular and therefore support the reduction of waste and better use of resources. We also, here on the bottom of the screen, we identify some of the sustainable activities and necessary activities that need to emerge to support in specific ways the circular transformation along the solar PV value chain. We also identified some new operations such as insurance that would need to emerge, particularly for installation and repair services and final product manufacturing, assuming that we use more circular second life strategies. And as you can see, we have two different types of circular economy loops here. So we have a second life strategies loop, which is going here on the bottom through component testing and product component resale services, which means that the solar panel as a whole does not go into recycling, get shredded, or get disassembled and melted into materials that then go back into primary material production. Instead, we reduce the work that is required in this process, and we retain the value of those products and those components to a greater extent. On the top, we also have another closed loop, which is through material decontamination of specific components of the solar PV going back into primary material production. And when this happens within the same material, so for example, aluminium gets recycled into aluminium, glass gets recycled into glass, we call it the closed loop system, where there is minimal loss of material value. However, sometimes this process is so-called open loop system, where some of the material value is lost. And this is very much where recycling services are largely at the moment, where a lot of material value is lost when most of the material embedded in a solar PV are shredded and used in activities such as perhaps cement manufacturing. So this is ideal, this is lovely, it would be great if we can make this reality. However, we identified many reasons why we should be doing this, and then some challenges. And if we move on to the next slide, I will just briefly map out some of the opportunities associated with improved circularity. So there is obviously a number of environmental benefits which have already been mentioned by colleagues on this call. So potential reduction in landfill use and hazardous waste pollution in the environment, but also reduction in the environmental impact of each PV and some carbon emission savings associated with more efficient use of materials as well, and longer lifespans of products through remanufacturing. There is significant economic opportunities here, and we map them out in our report. There are opportunities for businesses to generate substantial revenue through circular economy innovation, and this will support innovation and economic growth. There is a growing global market for recovered solar PV materials, as well as second life strategies and recycling technologies, as more and more countries find themselves in the situation where they find a lot of solar PVs that they need to dispose responsibly to avoid the potentially adverse impacts. There are also a lot of geopolitical benefits here, such as reduced reliance on critical raw material and solar PV imports. Well, circular economy for solar PVs has a huge potential in mitigating supply chain risks and enhancing energy security. And last but not least, there are social benefits through job creation in many of these circular economy activities. And however, this is not easy. So this is what the benefits would be. There are some challenges for us to get here, and I will hand over to my colleague Pamela from E.ON to talk a bit about those challenges and then the recommendations that we make for businesses and policymakers.
Yes, thank you very much. Pamela is just having some technical issues, but we will sort them out in a second, I believe. Or would you like to join here? Oh, she's coming online.
I think I'm back. Sorry for that. Sorry for that. Okay. So just catching up from where Sana left off, given the clear benefits that Sana has outlined, what are the challenges in moving to a circular value chain? In the report, we identified 4 broad clusters. They are listed in the slides. One of the most immediate barriers to increasing circularity is the widespread availability of cheap and highly efficient new PVs from China. Now, that's great for the environment and good for renewable energy uptake, but it's not so good for circularity in that it disincentivizes consumers from considering circular options such as second life PVs or repair, and provides stiff cost competition for providers of circular solutions. In the course of the report, we interviewed several recyclers, and the remaining challenges can be best viewed through the lens of a recycler. Now, what do recyclers need for profitable operations? First, they would ideally need consistent and high volumes of end-of-life PVs in order to reach economies of scale and to be able to plan long-term. They would also want to know where these PVs are located, in what condition they are, and how many to expect at any given point of time. Then they'd want to keep costs down by having distances between collection points and recycling facilities as short as possible. These factors are currently not in place. Waste volumes are inconsistent and fluctuate. The sorts of tools, digital tools to track and monitor where PVs are, the data sharing platforms and practices that would enable relevant pieces of information to be shared across the value chain are not widely deployed. And finally, the lack of localized recycling hubs lead to high transport costs, which we've been told can kill business case for recyclers. In this regard, policy gaps also don't help. There is no one single dedicated policy to encourage circularity in PVs. Instead, existing policies and frameworks which are not specifically tailored for this purpose can lead to confusion in the enforcement of key mandates, such as waste management responsibilities, or the lack of targeted incentives, such as on advanced recycling. In some instances, we also see how policy gaps can compound other challenges. On the technological side, for recyclers who are brave enough to undertake advanced and high purity recycling, because PVs are currently not designed for ease of recycling, EU recovery and recycling targets by weight, by mass, rather than by purity of material recovered, don't provide the right incentives to encourage this kind of investment. Next slide, please. So what can policymakers do? In the report, we outlined 5 sets of recommendations, and I'll just touch on a few. To start with, and most obviously, developing a single dedicated policy package to cover circularity in PVs would send clear and consistent signals to businesses. This would see treating PV separate from the current Waste Electrical and Electronic Equipment Directive, the WEEE directive, thereby bypassing some of its limitations on circularity. Within this, such a package, we would hope to see targeted incentives that would encourage market formation. This could, for instance, include VAT exemptions on repair and other second life services. There could be measures to boost consumer confidence and demand for second life products, such as quality standards or government-backed insurance schemes. Finally, given the international nature of the PV value chain, it would make sense to collaborate with trade partners outside of the EU to establish shared standards, for instance, for design and manufacture of PVs. Next slide, please. What can businesses do? That's a topic close to my heart as I work for E.ON. A common thread we've heard is that CO2 goals are good, but not enough. What we need are ambitious strategies and targets that incorporate but go beyond CO2 goals and place material and resource use at forefront. This could entail companies going beyond their core business areas and adopting circular approaches. How does this look like concretely? A retailer of PVs might, for instance, expand his portfolio to include Second Life PVs, or he might offer repair services. He would do this in partnership with a repair service provider, or he might join a buyer coalition to buy Second Life PVs. Buyer coalitions are also a great way we found of creating steady, consistent demand and markets for circular products, while demand and market formation is still weak. And finally, while circular solutions are still in early stages, we would need to see committed and deliberate investment until these technologies and solutions mature. More detailed examples can be found in the report. I've only had time to cover a few, but in closing, and to echo what Sana and Diana have said, while the benefits of circularity are clear, the challenges remain, and we see a clear role for businesses and policymakers to take the lead in creating the enablers necessary to foster greater circularity. And with that, I'd like to hand back to Munib.
Thank you very much, and thank you to our researchers to give an overview on the report that was done in collaboration with the IFM and the Cambridge Institute for Sustainability Leadership. Now, let's welcome our panelists. I'm very happy that we got a very interesting panel to give us some reflections on the topic of circular economy in the PV environment, and also to give maybe some complementary views on what was presented in the report. Of course, we wanted the report to be very neutral, and we kept our topics like industrial policy and or implementation in use cases in the industry. And that is why I'm very interesting to hear your thoughts. So I would ask every panelist to speak individually and share their thoughts first for 5 minutes. And then after everyone has spoken, we open the panel for questions. Now, first up is Eric van Berkel, who is a strategy consultant at Essent. Essent is E.ON's daughter company in the Netherlands. And I'm sure, Eric, you will talk a little about your circularity strategy at Essent. So, welcome.
Thank you. Can I share my screen? Is that okay? Can you see my screen?
Yeah.
Yeah, perfect. Well, thank you for the introduction. I'm working for Essent, indeed. So Essent is a daughter of E.ON in the Netherlands, and we have a strong focus on B2C, energy delivery and energy products, as we call them, such as solar panels, heat pumps, charging poles. I'm Erik. I'm working within the strategy department of Essent, and within that department we have an ESG team. And there I'm working with a strong focus on GHG emissions and circularity. And I want to talk you through a bit what we are doing at Essent. Starting with a bit of an overview of last year, because quite a few things happened, and it might give a nice view on what things are happening at the moment. So in December of 2023, we had an update of our ESG material topics, and circularity became one of them. So that was a new topic for us as Essent, which was also nicely in line with the study with CISL and IFM. Which started just a bit later. And during last year, we've been trying to set up like a circularity program. And because of that, I was also involved in like workshops with the study, And in one of these workshops, the idea of fully recyclable solar panels was identified as one of the key opportunities for the business. And yeah, that was something that I would really like to work further on. So that I will tell you a bit about in this 5 minutes. Just a month later, our board approved our circularity goals, which are that we want to become 100% circular in 2050, and to get there also 40% in 2035, so a bit earlier. And now we are doing a lot of things. So we just finished current state analysis on all of our material use and embedded CO2 emissions. And we did a circular recyclable solar panel feasibility study that I will talk to you a bit about later. And we came up broader with a roadmap on circularity, on what are the steps to take. Maybe to kick this off a bit, we looked at the embedded CO2 of our products that we sell to our customers, and we see that for Ascent, PV panels is like way the biggest category here, with around 2/3 of all CO2 emissions. So for us, this is really an important part. So it's really nice that there's been so much work on this. And as I told you before, we did a feasibility study on a proposition for fully recyclable solar panels. And we did this both for SME and for B2C. And for SME, we did some interviews, 8 interviews, like really in depth, 45 minutes, just talking to business owners, really to get their perspective on whether this would work for them, whether they would be interested in buying it. And we did something similar, but more quantitative for B2C, where we had 1,000 respondents and asked them about their whether they would be interested in such a product. So in a solar panel that would be fully recyclable. And what we saw here is that almost everyone really likes the idea. So for the B2C customers, for instance, we saw that 85% of the customers really likes the idea and would be interested. However, there's always, of course, a willingness to pay up until a certain level. So we saw that for SME, the willingness to pay was a bit higher than for B2C. So yeah, about 30% for SME that they would be willing to pay extra, 10% for B2C. But that there's quite a group there that would really want to buy it, and there are some small manufacturers that do this, that produce these kind of panels. So for our next steps, we are now in discussion with a small manufacturer, and we are setting up a partnership, which has now been done for a pilot, so we can start with a pilot. And for a pilot, we also want to start with have some customers, of course. One of the persons that we talked to from the qualitative research on SME was really interested, and he wants to be a launching customer. So we're now in the process of negotiating like what this would look like. But I think that this is a nice example of something that's like really concrete, and also a business opportunity for Ascent, where we think that we can actually also make money and find a part of the Dutch solar panel market that isn't really saturated yet. So it's also a business opportunity, and it also can really help circularity forward, which all started from the workshop with the CISL. So that was what I wanted to share with you.
Okay, thank you very much. Actually, I would have a lot of questions, but with respect of time, I would just ask our next panelist to give his comments and his views. Peter Handley is a professional with a background in European institutions, has worked several decades in this environment, and was also very dedicated to work on the EU Critical Raw Materials Act. And I would very much like to hear your opinion.
Yeah, well, my opinion of having worked for several decades is no. I saw Martin smiling. I did have a lengthy career, but I'm not Methuselah. I think my first reaction would be to congratulate Essent on the work it's doing, but to express surprise that for a mature renewable technology, one which is probably the cheapest way to get renewable energy out there around the world, that it was still so linear and still so very, very poor on the circularity front. I mean, it's quite shocking in a way, because we're going to see a major expansion of this technology in the coming decades. So the key point is we have to get our heads around the circularity, like today, not by 2045 or 2050. And I think also it's probably partly a problem that the way people look at recovery and waste recycling, they tend to think of the overall product and what percentage of that product you can recycle. They don't really break it down from the mass balance approach to identifying the things which may be quite small in volume, but the things you're really trying to get at, the critical raw materials, your telluriums and all this kind of stuff. So I think there's a bit of a failure in the system here somewhere. I think second point is clearly the right way to approach this is not to try and take some piece of kit that you have no idea what's inside it and you randomly try to recycle it. You should be trying to design for recycling from the very beginning of the process. And this is what's driving the European Union's sustainable products regulatory approach. It used to be the old eco-design just looking for energy efficiency, but now it's much more. It's energy efficiency and circularity, and really looking for these 4 R's at the stage of designing the product. So, you know, I'm not sure if they're already working on the solar PV panels, but it's certainly one of the areas that deserves attention. Another thing that can be done quite usefully, and here I think the European Solar Industry Alliance, which is run by EIT and Energy, has done some work on. It's developing product passports. So you do know as components move into products and go into use and then come out of use, you do know what you're dealing with, and you can more easily know the correct way to recover and recycle materials. I think the very last point I'd make is a bigger one that Professor Draghi identified in his report on competitiveness, and that's we really don't have what we need to have in Europe, which is a fully operational, well-functioning single market for waste. There's so much leakage of material outside of the European Union, which we can no longer really afford. And I think if you look at the recent announcements by the Commission in the Clean Industrial Deal, and what's been announced for the Future Circular Economy Act, you'll see that there's a much more robust approach being developed to making sure that value stays in the European Union, and that we really make a stronger business case for the demand side to want to be buying recovered and recycled materials or remanufactured goods that have a longer life. So I think there's still a lot of work to do to make this a thoroughly circular renewable energy sector. Thank you.
Yes, thank you very much. And without further ado, I would hand over to Martin Porter, who joined CISL from the European Climate Foundation and has a long track record working on industry, environmental and sustainability issues.
Thank you, Munib, and thank you, Peter, Eric, and all the colleagues as well. I guess by way of introduction, I should also say that although I'm executive chair of CISL Europe, I wasn't involved in this work and had the chance to read it afresh, essentially, when presented to us recently. And like Peter, congratulate everyone involved on a really useful, informative piece of work that was a pleasure to read. So I think it's really important that this type of exercise involving academics, companies and indeed policymakers is undertaken, particularly at this sort of moment, and it underlines, obviously, there's lots of interesting facts and figures in the report, how important this is as a general issue, but specifically focusing on solar PV in particular. And I think the utility of focusing on a value chain and showing how the specifics of that value chain need to work differently in order to become circular show that you can't take the same approach in every value chain for sure. But nonetheless, there are certainly lessons to be drawn in broader terms. I mean, one stat or one figure I think that Eric just talked about, which I think is important, is the embedded CO2 that he referenced being part of the conundrum. So this is an issue of how to make solar PV as a value chain more circular. But in doing that, you need to also address the climate impact of a linear value chain as well. So all of which suggests to me that this is further evidence that there's lots of opportunity, and I think that's been well expressed, as well as the challenges for businesses and policymakers as things stand at the moment. But we need to address these issues in order that they don't become problems. And the way that Peter said, you know, we can see that there is a growing waste problem, essentially, that if we don't address will become more serious upstream, and try and address them, much as policy is now seeking to do. But I guess the second point I would say on that is that, I mean, many of you said that this doesn't address industrial policy and industrial strategy, and I can understand the reasons fully for that. At the same time, from the start to the finish of this project, the world has changed, as we all know, sadly, very well. And what I think is much more clear now, using this type of report, is the importance of the circular economy and making all the progress that this report shows to our security and our resilience and our competitiveness through an industrial strategy that leverages all of these opportunities. So if there was one area that I think is worth further exploration, it's how in the policy recommendations, all of these issues also relate to European or UK industrial strategy. And I think an obvious example of why that's important is in the summary, it was mentioned that obviously there are many cheap solar PVs on the European market, basically coming from China, and that poses a problem for the dealing with this issue in a circular form, because they have not designed circularity in at the outset. They weren't subject to the sorts of thinking that we're now talking about here. And therefore, we're dealing with this as an after effect of having developed a system which is very, very dependent on large amounts of imports. And in other discussions, obviously, we've become familiar with the problem that leaving this as an issue that we didn't think about strategically 20 years ago opened the market up to large amounts of imports, which are less sustainable in circular and climate terms, even with all the benefits that they provide for decarbonisation of our energy system. So I think in order to get the answer to the fully circular system, we should also integrate industrial strategic perspectives. And indeed, I think Peter mentioned Professor Draghi's report. The implication that he laid out was that actually this industry now is so Chinese dominated that more or less we sort of we have to leave it to the Chinese. But maybe if we have a strategic perspective, next generation solar PV that addresses circularity might be something that we can develop more within a European context, particularly when the circular economy dimension is fully factored in, than we had previously considered. So those conclusions require us to factor in circularity, climate, and other sustainability issues with immediate security and competitiveness considerations. So I think this report will be really useful in addressing those issues now, as well as obviously addressing the specifics about circularity. And I'll finish just with a last point linking to other work that I've done on what we call competitive sustainability, which is that in order to solve these problems in any specific value chain, including solar PV, we have to integrate our thinking on the environmental, social, economic, and even the governance challenges upstream at the outset, in order to avoid the problems getting worse or being unsolved or making bad trade-offs when we're developing policy or indeed business strategies. And you're doing that now through this type of work. You're trying to address exactly that set of issues. But we need to do that systemically and systematically. And we need businesses as well as policymakers to engage in changing the rules of the game, the market demand, all of the regulations that frame that, such as that we create a new system, an overall circular system, rather than one that is still majority linear. And I think that's where the role of companies who can argue for that based on this type of work will be crucial as well, because that type of engagement in the discussion in the marketplace, but also in the policy arena, really requires forward-thinking companies to show how the system needs to be changed in order that those who are forward-thinking, have the relevant technologies, who are leading in this process, will be beneficiaries of it, but also we benefit as the wider public, if you want, from that process. So I think this report underlines the need for companies, businesses involved in this type of challenge to work with others to that sort of end. And I think the solar PV example is perfect for that. I'll leave it at that for now.
Okay, thank you very much. And please, audience, do not hesitate to type in your question. You can ask any of the speakers, either from the research team or from the panel. And yeah, but starting the discussion, I would pick up the thoughts that you presented, Martin. And now, of course, this linear production of PV also had benefits. Now, the sheer amount of PV that is currently being installed and produced, that was only possible by ramping up that mass production, especially in China. Now, would we not jeopardize the progress of the energy transition if we would include additional, let's say, restrictions? And how would you solve that?
Well, I think there are possibly two questions in that. One is, with the benefit of hindsight, would we have done the same thing 20 years ago or 15 years ago? I think we were developing a solar PV industry for all the reasons that you said. We knew that we needed to increase our ability to generate renewable energy. Solar PV is a clear example of where that technology enables us to do that, and therefore it made perfect sense to build that ecosystem of technologies, industries, and use up from that perspective. That said, when we were doing it, we weren't as cognizant as we now are of resource consumption and circular needs to be taken into account as well. And it may have been that we would have sought to develop the industry in a different way to that which it has developed in order to avoid the challenge that we currently have. But that's the benefit of hindsight. What we do now is not necessarily sort of sideline the question of how to make this much more circular, exactly what the report says, because we know there are huge benefits. But it does mean that we might make slightly different decisions at the margin as to where we source and how we source some of the materials and the way in which they are made in order to enable circularity downstream in a way which is clearly difficult. The challenges that the report lays out are significant, but were the manufacturing process informed by this thinking closer to the European Union and the UK, materials sourced differently, all of which could have been and could still be shaped by public policy, then the problem would possibly be solved more quickly or more easily, with those benefits still being achieved. And I think what we realize is that the climate challenge, the energy transition challenge, is not the only challenge we face, and we cannot neglect the challenge of the depletion of nature and the use of natural resources. We can't trade that off against solving the climate change problem. So we have to solve all these problems at the same time, as well as ensure we employ and keep industries developing in the UK and Europe, and make a success, if you want, in socioeconomic terms of that transition.
Yeah, that's an interesting thought, having this balanced approach through the different requirements and restrictions that we currently face, that be environmental, resource-wise, geopolitical. Peter, would you maybe like to add on that? If you introduce a European, let's say, policy, what are the challenges from your point of view to have this balanced approach between, let's say, our climate targets, our independency, our resilience? Yeah, what's your take on that?
Well, to a degree, it's already factored into Europe's new industrial policies, because at the same time as I was preparing with my team the Critical Raw Materials Act, the colleagues in the team next down the corridor were preparing the Net Zero Industry Act, and the solar value chain is one of the priority industrial value chains, which is subject now to all sorts of incentives to help them be built here in a way which is good for investment, good for jobs, good for skills, but also good for environment and for sustainability. And it does say concretely by 2030, we expect 40% of these different net zero industry technologies to be sourced from components that are made here in Europe, right? Which gives us will give us more control over the way things are designed. I think I would also add that a solar panel might look cheap because of its mass production, and people might just be looking at a limited set of information, which is not giving the full information. Okay, it's nice to know that it's going to give you power at so many euros per kilowatt, and it's going to be performing well for 5 or 6 years before it tails off. But if that information does not include the cost of the embedded CO2 emissions, the cost of the environmental embedded footprint, if it does not take account of somebody taking responsibility for the end of life recovery, processing and recycling, then it's not really a true cost, is it? So that's something that's driving quite a lot of European policy, partly about really getting beyond the very limited price per unit at point of sale approach and commoditization of things into a more thorough understanding of the true costs. And the second is, as Martin said in his first intervention, we're exposing ourselves very dangerously if our whole success for achieving climate and energy goals is outsourced to China or whoever it might be, because we don't control our own destiny. So there has to be some rebalancing and some value put on resilience and reducing strategic dependencies. And that's one of the things also the Commission has announced it intends to do in new approaches through public procurement.
It's I just received a question. The value chain of PV panels is clearly under control of China. How can we influence the Chinese industry to adjust their mentality to start designing and producing more circular products? Is that even something that you would recommend, that that we should, for example, introduce a regulation that would enforce a circular design parameters for Chinese production?
Well, it wouldn't be presented as we're producing design parameters for Chinese production. That would look a bit extraterritorial, but it's perfectly legitimate if you're dealing with the whole of the European single market, that you can say anybody who wants to produce in Europe or produce outside to sell in Europe has to respect the standards and norms that we set for our market. And that's what we're doing across the board for all sorts of machinery and equipment. So it would be not an exception. And the Chinese are very smart. They already produce for many products, the cheapest, dirtiest, right through to tailor-made for specific requirements in a specific market niche. It's not a problem for China to do that. You know, it's just a question of we have to decide where we want to balance the equation.
I understand. What I would wonder is, from the technical point of view, how difficult would it be to introduce such design parameters? Maybe that's a question for Diana.
I'll just took a time. Yeah, I think it is feasible, and actually there's a lot of research happening in terms of how to change the design of solar cells. And to be fair, especially on the research which is happening on the emerging technologies, there are many different groups looking at the topics already from the beginning, which is great to observe that this thinking process is taking place while the technology is in the early stage of its development, which obviously was differently with silicon PV. I think in general, there's always a question of costs associated to it and how to scale up the new type of designs and system setups. So in summary, I think it is feasible and there's a lot of happening in this field, but there is incentive needed, and this links back to the findings and recommendations from the report in terms of taking up these innovations.
Yeah, the report also lines out, of course, a tool set that could be used to incentivize circularity, with being, of course, neutral. But I would like to understand more, and that is a question to Eric. How strong is the market pull from your perspective already? Now, how large is the gap that we need to close with additional regulation, additional incentives to have an uptake on circularity?
Well, I think what we saw during the research is that overall, it's not something that people really start off with if they start off with looking for solar panels. So it's not really top of mind. However, if we explained like the benefits of having a recyclable solar panel without certain materials in it, maybe also locally produced, then everyone sees the benefits, and then they become enthusiastic about it. So I think there's some work to do in maybe also like the marketing of the whole circularity for the consumer market and the B2B market as well. And next to that, you see that at the moment, what was also mentioned before, that solar panels are being produced really cheaply, are even sold below production prices at the moment in the Netherlands. So it's very hard to compete with that if you are a local producer and adjusting to higher standards. So you see that there's quite a price difference now, which might be big for a lot of customers. So we're trying to see if we can find a place where there's some customers that are really interested just to start it off, and then the cost can go down. So that's what we're trying to do now. But there are some challenges there. So I feel that it would help if there's more legislation that it becomes more mandatory to have these more circular design principles, for instance. And then I think in the end we have to go in this direction. So we have to do something like that. Maybe to add, at the same time, I also was a bit surprised with the comparison of the prices of the solar panels that are fully recyclable and the price levels of like 2 years ago, before this whole very low point that we are in right now was there. So now the price difference is really big, but if the prices go up again of the normal panels, it's not that big anymore. So it might become way more easy, and then I really think that we can sell it quite easily, and then if it comes commercially viable, then we can really accelerate.
Maybe a difficult question for you to answer, Eric. Do you think that the view that you have in the Netherlands is transferable to other countries? Because obviously the energy transition is global. At least we need to solve it for Europe and our environment. And do you think that the Netherlands are ahead of the development there?
To be honest, I'm not sure. So in the research, we only interviewed people from the Netherlands. So that's a bit of a limited scope. I think overall what you see is that the Netherlands is, compared to the rest of Europe, not really ahead in thinking about the climate thing. So I think it could be transferable to at least some other countries. So there's some differences between countries, east and west of Europe, maybe. But I think, yeah, I think that a lot of people are also worried now about these what is happening globally, about supply chains that are really dependent on other countries. So I think that could help this case, actually.
Yeah, thank you very much. And Nadine, do you have a view on that, maybe with a broader overview on our activities at E.ON?
Yeah, I think just answering a little bit the question from Eric, I think that in the Netherlands, I think you did a good step from the government. You set your own circularity target for 2050. I think it's 100% or something. So I think it's a clear vision what you have in the Netherlands, and I think this is missing in most of the countries, because I mean this, and it shows in your case that there is certain interest from businesses, because this has an effect on the whole supply chain, and to achieve those targets. And I see this is a big difference compared to other countries in Europe, that you have done this step. Yeah.
And Nadine, to follow up on that, to zoom out a little, of course, we only started with circular economy and PV because it's somehow a pressing topic, because PV is aging, and we currently install like huge masses of PV, and that's why it is very interesting to take a look at circularity in that specific industry. But what do you see as the next steps, the future requirements for circularity in general for our industry?
I would say, first of all, I mean, it's important that, especially in that case, we are still looking in kind of new technologies. Yeah, I mean, there is a certain way or a certain moment where we need to finance a gap. Yeah, a gap to the market. And is it now a recyclable solar PV panel, or is it a fully recyclable battery? I mean, all these components that we are using. And I think it's important that there will be incentives, for example, on quotas in future. Yeah, quotas on a certain share on recycled contents, so that could accelerate markets around all these components. And I think that if we could solve this issue, and you can compare it a little bit with what is happening on the plastic market with the PET pellets. They introduced a quota for just for the bottles, but you see now that the prices they're going very high for these PET pellets, and so there's now a market. Yeah, and we can discuss that. Yeah, I mean that people that are not so happy with those developments in the PET market, but it helps to accelerate and create new markets around it, new startups, and so on. And I think this would definitely help here. Yeah. So from my point of view.
Learnings from other industries and taking over regulations and experience from there. Sana, would like to add on this idea? Where would be the limitations of such an approach? To learn from other industry and copy, let's say, regulation for the energy industry, and taking advantage of the experience that has already been made in other areas.
Sure. So one of the things that we have emphasized in much of our work, particularly in relation to foundation industries, is the role of demand, and how important it is to create those markets, create that demand. Because if we look at the value chain, both linear but ideally the circular, we realize that in a circular economy, none of the stakeholders across the value chain is only a producer or a consumer. Every stakeholder across the value chain is both a consumer of the of the product that they are purchasing, and they are a producer for how that product gets processed further down the line. And therefore, everybody across the value chain plays a hugely important role in terms of facilitating their transition to a more circular economy. So what we need to do through policy incentives particularly, but also incentives for businesses to take action and incentives for consumers to take action, is to create that demand among businesses for recycled material, for reusable components and so on, from consumers for solar PVs that are perhaps remanufactured instead of being brought over from China. So all of these demand aspects need to be created across the entire value chain, and only by addressing all of those demand questions and creating demand across the value chain can we actually look at a situation where people start preferring or choosing a more circular product as opposed to a newly imported a product from China, for example. So the role of demand is hugely important and cannot really be understated. In previous research, we have looked at the role of demand in incentivizing innovation in foundation industries. So how creating demand for things such as hydrogen in foundation industries could incentivize the take-up of hydrogen by foundation industry, primary material manufacturers and so on. So I think there is a lot of learnings that we can take from other studies and apply them into the solar PV value chain.
Mm-hmm. Okay, thank you very much. Now we are approaching already the end of our webinar. I would like to ask you maybe to have each of you a final statement of the main learning that you had from your engagement in circular economy. Let it be short or long. I mean, the engagement, not the statement. The statement must be short. So yeah, and since you were just talking, Sana, would you like to summarize maybe some aspect that you find very important from your experience?
So drawing on this specific research, one of the things that I would emphasize coming out of this report is the multi-stakeholder approach, the fact that all the stakeholders need to act together, and the enabling stakeholders, whether that is data providers that enable data to be collected in a standardized manner and shared in a need-to-know basis, whether it's financiers or policymakers, the need for all stakeholders, both in exogenous and those that are right on the value chain, to really act together and figure out what do they need to do to enable greater circularity, not just in their own operations, but also in the operations of the other stakeholders across the value chain.
Thank you very much. Diana, would you like to add something?
Yes, sure. Actually, adding to what Sana was just saying, when you go to the report, we have actually conducted also a comprehensive analysis in terms of what are the value opportunities for different stakeholders, the existing stakeholders and the new stakeholders, or those who are basically needed to enter and get a new role in the new circular world. And from this analysis, we actually identified a wide range of opportunities for a wide range of value creation. And this can be both, it can be monetary, so in terms of opportunities for new business models, but also in terms of value, which can be kind of more intangible value like knowledge sharing and innovativeness, etc., etc. So I think there's a lot of potential, but there's also a lot of need to work and collaborate together to basically move to this new world.
Mm-hmm. Okay, thank you very much. Pamela.
Yes, building on what Sana and Diana have said, I think that specific to this report, we identified an extensive list of barriers and enablers, what would be necessary for increasing circularity in the PV value chain. But I think that these are, and taking one step, zooming out now to the bigger picture, I think that these are also applicable to many of the other components, as Nadine mentioned, that we use in the energy industry to accelerate the energy transition. So to wind turbines, to heat pumps, to batteries. And it would be really interesting to see if there could be a blueprint created on the basis of a report like this to increase circularity in other value chains for the energy industry as well.
Okay, thank you. Eric.
Thank you. I think one of the things that comes from the report is that we have to explore opportunities to transition or expand existing business models. And I see a lot of opportunities there, not just for PV, but yeah, we have now this whole plan of what we want to do, and there's just so much waste in the linear economy. It just makes no sense, also not from a business perspective. So I fully agree that some things have to change in regulations, but I also feel that with a bit of an entrepreneurial spirit, we can already do quite a lot. And yeah, I would also encourage everyone to think about what this could mean for himself or herself.
Thank you very much, Peter.
Well, we already talked a bit about the role of industrial policy, but I think there's also a role here for trade policy, because clearly if materials are being sold in huge quantities on the European market at less than the price it costs to make them, we're talking about dumping or even subsidies. So, we have trade defense measures in the European Union, and I think you might need to consider that, or tariff measures, not quite a la Trump, but you have to think about your own economy and its ability to resist unfair trade practices. And at a time when Europe has said that the solar PV channel supply chain is something we want to rebuild here, after all, it was invented here, we need to give our industry or value chain a chance to come back into the market and be protected against unfair competition from China.
Mm-hmm. Yeah, thank you very much for adding this aspect. Martin.
Yeah, I fully agree with Peter's point. I would add two additional thoughts. I think building on what Sana and Pamela both said, I think creating the market demand for a more circular economy, specifically in this area, clearly, in addition to the entrepreneurial spirit, if you want, that Eric spoke about, requires public policy intervention to shape that market, to build that market up, whether that's mandates, quotas, standards, rules, and so on. It's, I think, particularly now, really important that the right balance in that type of regulatory or public policy intervention is struck when there is so much discussion about, at a broader level, the European Green Deal needing to be simplified, which some are interpreting as deregulation, which can go in exactly the wrong direction if you're trying to create a market like this. So this is a case where the business can be supported by the right type of public policy intervention, and it will be beneficial for the businesses, Europe, and so on. The second point comes back a bit to what I said at the start. I think to win those arguments now, the case that this is going to be beneficial from a security and a resilience perspective is the trump card that has to be played. However much the environmental dimension is of concern to all of us and to anyone working in this space, the winning arguments, I think, much as Peter was saying on trade and industry, will be if we can demonstrate that this is going to make us more resilient and safer. And that will then lead to those public policy interventions being the ones that you need and that we want, more so than the environmental arguments. Much though I don't like saying that, I think that will be the short-term imperative for us to rethink how we sell this.
Okay, thank you very much. And half a minute left, Nadine.
Okay, so half a minute. Then I would just say, I think we just should sit together and start acting. Yeah, I think that's the important thing. We should not lose the time. I mean, we have now the information together, and this piece of work, I think we have everything in our heads, and now it's really important that we do not lose that moment that we have now to sit together with people along the supply chain. And as Eric, you mentioned, SN, just start with something. Yeah, and I think that's my learning so far. So stop talking and start acting. Yeah.
Okay. Yeah, these are very nice last words for our webinar. Thank you very much for listening. You can access our study via the link that is given here, or the QR code. And the last thing that I would like to mention, there were also other people involved in the making of the report. I would like to acknowledge the other contributors from CISL, Edmund Dickens, who's actually here in the room, and Anam Shaikh, and Imo Ilyas Bauer, and Awal Abu Bakr from the IFM. So thanks everyone, and have a good evening, afternoon. Bye.
Bye. Thank you.
Thank you very much. Bye.
Thank you. Bye-bye.